Hi all and welcome to this second video of the module. In the previous video we introduced the general concepts of Sparkle, the query language for the semantic web and linked data. In this video we will see how to build Sparkle queries by means of different examples. So let's start with a really simple dataset, the simplest one actually, a dataset containing just one triple. We have here that we have an individual representing a book with a title and a value. That's all. So let's see how to get the title out of this dataset with a Sparkle query. What we will say is that we want to select the title, a variable named title. We denote variables with the question mark, and that, or where it happens that there is an individual book 1 that has the property title with the variable we were asking for. In this case, this is the pattern we are defining. When we match it with our data, what we will obtain, of course, is that the title is a Sparkle tutorial. So the triple pattern that we define on the where clause is matched against the RDF data. And as we will see later on this video, we have 4 different constructors: select, construct, describe, and ask. So let's see here how we can query this data in which we have different individuals A, B, and C, and for each one of them we have a name and a mailbox, except for the last one in which we only have the mailbox. So if we execute a query saying, okay, select both the name and the mailbox for an individual X that has a property FOAF name with any name, and the same individual X that has a mailbox with any mailbox that we are selecting on the select clause. If we match this pattern against our data, what we will obtain is that John Lee has the JLo mailbox and the Peter has the Peter mailbox. So those are the 2 individuals that we are getting, that is A and B. We are not getting C. Why is that? Because in this case C doesn't have a name, so we are not meeting this part of the expression, the FOAF name property, so we cannot retrieve it. We'll see how to deal with this kind of situation later on this video. We can include literals in our queries, doing special things for them. If we recall the RDF video, on the right part of a triple we can have either an object that is a result, or it can be as well a literal, that is a date, a string, or a number. So when doing queries in Sparkle, we can select here, for example, an individual B, where that individual has the property, any property, in this case yes, it's going to be P, related to a string cat, which is annotated in English. This is how we define languages in RDF, and we can use that to query data in Sparkle. We can as well ask for an individual that has a property related to a numerical value, or we can specify that this individual must be related to a specific value, in this case ABC, of the type special data type. We can include the data type as part of the Sparkle query. So we can work with raw numbers, with strings annotated in a given language, or with specific data types. We can also use more complex expression. We can filter our results based on, for example, regular expressions. So in here, what we are asking for is from these datasets in which we have different books with titles and prices, we are asking in this first query to get the individuals, an individual with a title, and that title here must meet this regular expression. That is, that it must start with the word Sparkle. So in this case, we are retrieving only this title over here. We can as well do other kinds of expression. In this case, we are filtering, as in the previous case, but in this case, we are asking for the title to contain the word web, and specifying here that we don't care whether it is uppercase or lowercase. So in this case, we will match the second title, that is the semantic web title. We can also filter based on comparison. So in this case, we are asking for titles and prices here in the query. We want the book to have a given price and a given title, but we want the book to have a price that it is, in this case, as we are denoting here, lower than 30.5. So in this case, the only individual matching this filter is the book entitled The Semantic Web, which has a price of 23. All these expression, all these filters can be implemented using xquery and xpath functions and operators. We have operators for comparing values, such as greater than, less than, equal, different, etc. We have functions to determine whether a result is an URI or a blank node or a literal. And as we saw in the examples, we have regular expressions. We can filter based on the language. We can filter based on the data type or on the content of the string. We have optional parents, and that's the solution for the problem we saw before, for when we faced a dataset in which not all the individuals has all the properties that we expect. So in this case, for example, we have A, which is of type person. It has a name and also a mailbox. We have B at the bottom of this example, which is also of type person, but it has only a name, but it doesn't have any mailbox. So if we execute this query asking for both the name and the mailbox, as we saw before, what we are getting is only Alice, because it's the only individual that has a name and a mailbox. But if we say that the second part, that the mailbox is optional, as we are denoting here, we will obtain both. We will obtain Alice with the name and the mailbox, and Bob only with the name because it doesn't have any mailbox. So what we are saying here is, give me all these properties, and optionally, if you have the mailbox, if you have this property, I want it as well. But if you don't have it, it's okay. Give me the result anyhow. We can have multiple optional parents. In this case, we have Alice with a home page and Bob with a mailbox. We can put an optional on the mailbox and another optional on the home page, here and here. And we will get is, in both cases, the name, and for Alice, the home page, and for Bob, the mailbox. We have to be careful when using multiple optionals, because every time we put an optional on a query, we are allowing more results to be matched. We are allowing more results to pass our query, which means that it will increase the volume of the results and the time required for executing the query. So the more optionals, the more complex the query is. We can as well specify unions. In this example, we have two vocabularies. We are defining two vocabularies at the top of the example. In both cases, it's DC terms, but in the first line, we are defining version 1.0, and in the second one, version 1.1. We have different annotations, as you see here. Some of them with the 1.0 version, some of them with the 1.1, and some of them with both. So if we want to obtain both results, what we can do is to union them. We can say, okay, select all the books with a title annotated with DC 1.0 and DC 1.1, and with the union clause, we will be joining them together. So we will obtain all the results annotated with the different properties, with the different versions of the property. We can also use this union to obtain all the results, but separating them, splitting them into different values. In this case, instead of using one single variable, as in the previous example, we were using title, we are using here X and Y. So X is for titles with 1.0 and Y is for titles with 1.1. In this, doing this, we know which value was annotated with which version of the property. As well, we can introduce more complex patterns in our queries in the clause of each query that we are joining. So we can say, I want books with title with the 1.0 and creator with the 1.0, join with the titles and creators with from 1.1. We can also work in Sparkle with name graphs. If we recall the video from RDF, we said that an RDF dataset can be composed by many RDF graphs, each of them containing different triples. So we can introduce on an RDF dataset a name graph, which is a graph with a specific ID that we can use to query or to manage the information that is contained only on this graph without affecting the others. So in this case, we have two different graphs. We have the Alice FOAF graph and the Bob FOAF graph. As you see, in both of them, we have defined a mailbox for Bob, which is this one here and here. But in the Alice FOAF dataset, we have a nick for Bob, which is Bobby, and on the other one, the nick is Robert. So we can execute a query saying, well, give me the nick, in this case the variable nick, from the graph Bob FOAF. We are specifying here which of the two graphs we want to query, where there is an individual with the mailbox we saw before, which happens in both graphs, and we want to take for this individual the nick. So as we are specifying that we want to run this query against the Bob FOAF graph, we are only obtaining Robert as the nick. If we leave it open, if we say, okay, I want to select the nick as well as the source, the graph source, we do not specify any concrete graph, and we run the same query, what we will obtain is that the nick is Bobby in Alice FOAF, as we saw before, and Robert in Bob FOAF. In this way, we can select which graph we want to use to run our query, that is, which part of the information we want to work with. So we have a set of modifiers, a set of operations that we can apply to our data once it's retrieved to modify how it is displayed. So for example, we can say, we can use the order by clause in which we will order the results we are getting. In this case, the name, we are ordering our results alphabetically based on the name. We have the distinct clause in which we are saying that all the results that we are having or retrieving here as the name must be different. And we have also the limit clause in which we say, I only want, in this case, 20 results, the first 20 results that you have. We have also the offset, as in SQL, all these modifiers are close to what we have in SQL, in which we say, for example, offset 10, meaning that the results that we are getting will start on the 10th and forward. So, as stated before, we have 4 different constructors for our queries. The first one, which is the one we have been using in these examples, is selects, which allow us to define which are the variables that we want to retrieve from the where clause. So in this case, we are saying that we want to select both name, xname, and yname, and nick y, which are variables that we have been using in our where clause, obtaining the results that we can display as a table, as we see here, for each of the variables on the select. We have construct, which allow us to build new RDF triples based on the results of a query. So for example, if we have this data you see here, in which we have the name of an individual and the mailbox, as we have seen in the previous examples, we can define this query in which we are retrieving the names and using these names to construct new triples. What we are using here, it's a template in which you say, okay, build new triples with the individual Alice, annotated with the property bcar full name, and the name that we got from our query. So in this case, we are going to retrieve the Alice name from here and build a new triple based on the template. So Alice, full name, Alice. We also have the ask constructor, which is a constructor that allows us precisely to ask our data whether a triple exists on our data or not. So for example, here we can ask whether there is a triple that or a pattern that meets that an individual has a FOAF name with the value of Alice. If we go to our data, it happens, it is appearing here. So we will get a yes. We don't get the results, we get whether they exist or not. This is really useful when we are querying large Sparkle endpoints, large data sets, in which we first want to be sure that our query makes sense before having to execute it. This is much faster, as soon as the query finds one pattern that meets our requirements, it returns yes. And finally, we have describe, which is a constructor that allows us as well, again, precisely to do that, to describe a resource, to describe the triples that are around a resource. So for example, if we want to describe X, an individual X, where that individual has an employee ID 1, 2, 3, 4, that is, we are asking for any employee that has that ID. With the describe constructor, what we are getting is that, of course, there is an individual with that employee ID. Also, that employee has this mail signature, information about the employee name, and that this property, about the mailbox, is of RDF type all inverse functional property. That is, we are getting information, triples around the individual A, but without having to do any complex query about it. We let the Sparkle engine to tell us what triples are around my individual. It could be that there are more triples in my dataset, but those are the ones that are just around my node, the node with the employee here on the RDF graph. And with that, we have finished the Sparkle module, in which we have seen which are the main concepts of Sparkle, and as well we have seen how to build queries with the different capabilities that Sparkle provides. Go ahead and try any of these queries on any of the Sparkle endpoints we saw on the first video to see how they work.